The two halves of the rope that runs over the pulley shown here make an angle of 35 degrees. If the diameter of the pulley is 2.5 meters, find the length of the rope which is in contact with the pulley. Consider significant digits. Let's have a look at the sketch provided. We are looking for the arc length from point A to point B, and I am going to make it more clear. We are looking for this length. If we draw from the center of the circle, which I'm going to show it with O, to the point B and to the point A, and if we call the point of intersection between the two lines perpendicular to OA and OB as M, we have four sides, the four sides AM, MB, BO, OA. What is given in this problem is this: the radius, which we can calculate, and also the angle 35 degrees. But what we need to find is the arc length AB. We know that we can find the arc length AB if we have the angle facing the arc length inside the circle. So if we have this angle, which I call O, then because we have also the radius, we should be able to calculate the arc length AB. However, we need to calculate the angle O first. We observe that angle O plus angle A, which I am showing in the graph, plus 35 degrees plus the angle B is equal to 360 degrees. But at the same time, the angles A and B are both equal to 90 degrees. Therefore, angle O is equal to 360 degrees minus 35 degrees minus 90 degrees minus 90 degrees. This is equal to 145 degrees. In order to find the arc length AB, we need to have the angle O in radians. Therefore, we're going to convert 145 degrees into radians. The conversion factor would be pi over 180 degrees. Please note that because 145 degrees is in the numerator, because we can look at this as 145 degrees over 1, therefore 180 degrees will be in the denominator and pi will be in the numerator. If we simplify this fraction, we will get 29 pi over 36. If you pay attention, I am not converting this into a decimal number. The reason is that if I convert this into a decimal number, I'm creating errors in my calculation. If I keep the answer as 29 pi over 36, this is as accurate as I can be. Now, we need to find R, which is the radius of the circle. That is half of the diameter. So that would be half of 2.5, which is 1.25 meters. Now the arc length AB, let's look at the diagram. The arc length AB is equal to the radius times the angle facing the arc length. Therefore, I can say that AB is equal to the radius times the angle. Or in fact, I am writing L is equal to R alpha, or L is equal to R theta, which you may be more familiar with, but these are essentially the same. Now I can plug in for R, that would be 1.25, and for O I can plug in 29 pi over 36. And if we calculate this, we will get 145 pi over 144. Should we leave the answer the way it is? Actually not, because this number has many significant digits, but they're not all significant in our problem. Let's write this in decimal form. In decimal form, this is approximately 3.163409269. But of all these, and so on, but of all these digits, only 2 are significant. 2 significant digits. And the reason is that in the original data, there were 2 numbers which were important. One was 2.5 meters, which has 2 significant digits. The other one 35 degrees, which has again 2 significant digits. The number pi has an infinite number of significant digits. The lowest number of significant digits in this problem is therefore 2. That's why we have 2 significant digits for our final answer. Therefore, this rounds up to 3.2 meters. We note that we would have to keep 2 significant digits only. Therefore, we would have to cut whatever is after 1. But because 6 is more than 5, or 63 is more than 50, or 634 is more than 500, and so on, we would round the 1 appearing before 6 into a 2. This is the final answer.